Okay, good morning. So, as I told you, I will go to the next chapter, which is the topic of trigonometry. But the first part I skip for the time being. There are three important theorems related to triangles, which doesn't need that much trigonometry more than Math 1C or 2C. But they are extremely important theorems and they will not be repeated in Math 4. So, but they are important. So you have to learn them here and try to remember them, at least the names. Okay, so these rules or theorems are the area theorem, the sine theorem, and the cosine theorem. Okay, so I will probably cover the area theorem and a little bit of sine theorem, and then we will leave the next theorem for the next session. That's the cosine theorem. And then after I give you one session probably to practice, then we come back and cover the first part, which is actually extremely important. So let me just start a little bit of refreshing your memory. So you know that we started trigonometry in a right angle triangle, so we defined some trigonometric values. So for example, if I have a right angle triangle, so assume that this is my right angle triangle, the right angled vertex, I call it for example A, this one B and this one C, and then if I have two acute angles, one B and one C, of course they add up to 90 degrees. And if two angles are added to 90 degrees, they are called complementary. So 30 degrees and 60 degrees are complementary angles because the sum is 90 degrees. Okay, and then we, in Math 2C and of course 1C as well, we defined, there is no proof for this, we define if you are interested to find the sine of an acute angle, I emphasize, an acute angle where only in right angle triangles, only. Then if you want to do it, by definition, it becomes the length of the opposite side to the angle divided by the length of the hypotenuse of that triangle. So if you don't mind, let me write like this. Sine is equal to, if you want to spell it completely, sine is defined to be the opposite side divided by the hypotenuse, okay? These are acronyms assuming that for opposite and hypotenuse. And then if I want to define cosine, this becomes the adjacent, for example, let us use this acronym for adjacent and then divided by hypotenuse. And then if I want to talk about tangent, this is not a tangent line, of course, that's just a number. It's defined to be the opposite divided by the adjacent. So this you can have it as a rule of thumb in the back of your head. But then you can apply it to each context. But remember, these formulas are only valid if I am working with an acute angle and only in a right angle triangle. That's it. Okay, so for example, in this setup, I can talk about sine of B. I can talk about sine of C, but I cannot talk about sine of A yet. Yes? So sine of B is the opposite side. And by the way, that's completely conventional in mathematics, that if you have a triangle and if you name them with capital letters, the opposite sides are denoted by smaller, this lowercase letters corresponding to this opposite. So for example, if I show this with capital A, the length, not the line segment itself, the length of the opposite side is denoted by little a, the length of the opposite side is denoted by little b, and the length of the opposite side to C is denoted by little c. So in that case, sine of B becomes the opposite side, which is B, divided by the hypotenuse, which is A. And then you can see that cosine of B is equal to the adjacent side. So be careful that you are not mixing adjacent. So if you see here, this is angle B, both my fingers are adjacent to it. But this one has a different name. That's not called adjacent because the name of this guy is hypotenuse. So when I say adjacent, even though technically both of them are adjacent to this angle, but when I say adjacent, I mean the one which is adjacent and is not the hypotenuse. So there's only one option left, and that is C divided by the hypotenuse. And then you have tangent of B. What happens here? The tangent of B is the opposite divided by the adjacent. For the same reason, adjacent is C, not A. Yes? I can talk about sine of C. I can talk about cosine of C. I can talk about tangent of C. Because C is also an acute angle in the same right angle triangle. Yes? So what is sine of C? Sine of C means opposite to C is C, because sine is opposite divided by hypotenuse. So it becomes C over A. And cosine of C, for the same reason, two sides are adjacent to C, but one of them is called the hypotenuse. So the other one is called the adjacent one, which is B divided by hypotenuse. And then this one is the opposite one, which is C divided by B. And yeah, more or less you immediately recognize a nice pattern, even if you don't follow, if you don't go forward anymore. You see sine of B is B over A, and then on this list cosine of C is also the same number. And then you see this is the same happening here. So this means that, this is by the way a generic rule, we will learn that, at least it is completely clear in this picture, that if two angles add up to 90 degrees, the sine of one of them is equal to the cosine of the other one and the other way around. Okay, so that's an important remark, which probably you will face it if you are studying mathematics, even in university. So that's an important thing to remember, okay? So that's the sine of an angle is equal to the sine of its complement and the other way around. Yes. By the other way around, I mean the cosine of an angle is equal to the sine, I have to fix it. The sine of an angle is equal to the cosine of its complement, and the other way around. It means the cosine of an angle is equal to the cosine, is equal to the sine of its complement. So for example, if I ask you, do you know sine 15? Even I don't know, I don't have it in my memory, sine of 15. And I don't know cosine of 75 either. But what I know that these two numbers are exactly equal. Because 15 and 75, they add up to 90, they are complement. So sine of one of them is equal to the cosine of the other one, and vice versa. So that is some pattern that you can see from here. What about tangents? Tangents are reciprocal. Why? Because tangent of B is B over C, tangent of C is C over B. So this means that if two angles are complements, alpha plus beta is 90. So you can take this as an example of this remark, and let me write this part 1 and part 2. If alpha plus beta is 90 degrees, then what can I understand? I can understand that if I multiply these two tangents, the answer becomes 1, exactly. So if I ask you what is the tangent of 15, I don't know. What is the tangent of 75, I don't know. But I know that this product exactly is equal to 1. Yes. That's also something that you can see from this setup. Another pattern is that, which will, of course, we will talk about this in more general form later. For example, let me take this one and this one, square them and add them. Yes, you might say why, because let us see how it goes. So sine of B squared plus cosine of B squared. Let us see what will happen if I do this. You might say why I'm doing this, because it becomes a very nice formula at the end. That's it. So instead of sine of b, I can write b over a squared. And instead of cosine of b, I can write c over a squared. But this becomes b squared over a squared plus c squared over a squared, but the denominators are the same. So I just write the same denominator, and then I add the numerators. Okay, so it's b squared plus c squared. But suddenly b squared plus c squared is equal to a squared because of Pythagoras theorem, yes? Then it becomes a squared over a squared. But the a squared over a squared is really not dependent on the value of a, because what value a is, this answer is always 1. And that's why it's the nice formula. So if you have sine of an angle, square it, cosine of the same angle, square it and add them, it's always exactly equal to 1. And it doesn't depend on the value of the angle that you are choosing. In this setup, the angle that you are choosing should be an acute angle. It means that it should be between 0 and 90 degrees. But then when we covered this part and I went back to the first section, we will actually generalize trigonometry to be able to cover angles higher than 90 degrees and things like that. Okay? Then you will see that this formula is still valid if I go to that context as well. So this in principle, this is a fundamental theorem of a very fundamental rule for trigonometry, and which is representing the Pythagoras theorem in some way. Because the reason that this formula was correct is because of the Pythagoras theorem. So if I would say that Pythagoras theorem is a geometrical version of Pythagoras theorem, if you want to write the trigonometric version of the Pythagoras theorem, it becomes this trigonometric formula. So sine of, by the way, this is common that people drop this pair of brackets, but they don't write it like this, because usually people read it b squared sine. Of course, this is not a matter of confusion because angles cannot be squared. But anyway, this is common. Instead of putting 2 here, it's common to put 2 here. So instead of writing, of course, there is no problem if you want to write it like this, but this is common written in this form. Sine squared of an angle. Let me write it. Let me write theta. Usually Greek letters are used to denote. It doesn't matter, of course, but let me use theta. Sine squared theta plus cosine squared theta is equal to 1, regardless of the value of the angle theta. Yes? Yeah.
So does that mean that sine squared of theta plus cosine squared of theta is equal to the other with the tangent, tangent 15 times sine 75, because they're both equal to 1?
Yes, of course. But theta is an angle. 15 and 75 might be different angles.
Okay. But if you take the same angle, then they're equal.
Even if yes. No, these two cannot be the same angles, because one of them should be the complement of the other one.
Yeah.
Yes. Okay. For example, if I ask you, what is sine of 22.5 degrees squared plus cosine of 22.5 degrees squared? I don't know any of them individually, but if you ask me about this particular combination, I'm confident that the answer is exactly 1. Yes, sine squared of an angle plus cosine squared of the same angle is equal to 1. So what's your opinion about this? Sine squared 15 degrees. This is the way that I read it is wrong. I have to read it sine 15 squared, not sine squared 15. Okay, but sometimes I do it, I don't know. So sine 15 squared plus sine 75 squared. without calculator, can you calculate this without calculator? But this time I have chosen both of them sines. Yes? What is your opinion about this? Yes?
Sine 15 can be written as wait. Yeah, sine 15 can be written as cosine of 75.
I do it the other way around, but that's correct.
Oh, okay, yeah.
So instead of sine of 15, I would write sine 15 squared. But instead of sine of 75, we just learned that I can write the cosine of its complement, which is 15 again. Yes. And then, what can I do? The answer becomes what? Exactly that pattern. Now I have sine squared, cosine squared, but they are of the same angles. Okay? So then, definitely the answer is again 1. So for this one to work, of course, one of them should be sine, the other one should be cosine, and the angles should be the same. The question that I ask you is not directly that pattern, but if you combine this one with the remark, you can solve it, yes? So instead of sine of 15, I just copied and pasted this part, and instead of sine of 75, I wrote cosine of 15, and then I kept this pattern now to the answer as well, yes? Okay, so for example, what do you think about this scenario? Sine to the power of 2, 10 degrees, plus sine to the power of 2, 20 degrees, plus sine to the power of 2, 30 degrees. And let me continue this list until sine squared to sine of 90 squared. And I calculate this without calculator. It's not good, so let me see. Let me stop at 80. So, yeah, let me stop at 80. Of course, I could continue to 90, but you haven't studied sine of 90 yet. But in principle, we should be able to calculate this. So 10, 20, 30, 40, 50, 60, 70, and 80. Sine squared of these angles. I want to add them up. Can I do this without the calculator? Yes, that's the yes.
Isn't sine 80 squared the same as cosine 10 squared?
10 squared. So it means that I have to group them. Yes. So what I want, the question mark, I will rearrange them in this way, as Gustav mentioned. But the point is what Gustav mentioned. Let me just rearrange them first without changing anything. And then, for example, what do you think I will do next? I will take 20 degrees and put which one next to it?
70.
70. It's clear now. Yeah. So it becomes sine squared 70. Yes?
Yes.
And then hopefully you agree with me. I can go up to where? So 10, 20, and then how much I can go? 40 and 50, I think, yes. I don't know, might be it was a good idea to write it down. Okay. Because there's only one left. Let me just, these dots are more or less meaningless, yes. So then, just one more term. Let me just write it. And then one more term. Oops, 50. Okay, but now, so this is the first thing that you do if you want to answer this question. The next step, you have to mention that, okay, sine of an angle is equal to the cosine of its complement. So instead of sine squared, instead of sine 80, I put cosine of 10, but because I have a power of 2, this becomes this. And the next one, the same story. And the next one, the same. Yes. And finally, the last one. But now every pair forms the same pattern that we have, yes? So remember, that's an extremely important pattern. Sine of an angle squared plus cosine of the same angle squared is always 1 regardless of this value. So it becomes 1 here, 1 here, 1 here, 1 there, yes? And this becomes 4. So the answer to this sum, even though many of them we don't know the exact value, but we know the answer to this is exactly 4. 100%, and the error is 0. Okay, what about this one? I'm just deviating a little bit. I haven't talked about the area theorem. I'm just refreshing your memory a little bit about the
Why did
trigonometry.
you group them like that in the first brackets? Like 10 with 80 degrees, 20 with 70. Yeah, why did you group them?
Because I want to have complements next to each other.
Oh, okay.
So because all of them are sines, if I want to use this pattern, I need one sine, one cosine. And then instead of sine of 80, I was able to write cosine of 10. Because 80 and 10 are complement. And then these two become the same, I can use the pattern. Okay, so for example, what about this? Logarithm of tangent 1 plus logarithm of tangent 2 plus up to logarithm of tangent 89. What is this answer? So what does it mean? I have 1 degree, I take the tangent of 1 degree, it becomes a number. I take its logarithm, in the base 10 of course. I do the same thing for tangent of 2 and I continue this list until tangent of 89 and I start adding them up. So what will be the answer then? Of course, somehow this will be involved, this rule. If alpha and beta are complementary, the product of the tangents is equal to 1. But that's not a product of tangents, but of course, you need to remind yourself about the property of the logarithm. Yes, do you want to say something, Rocco?
Yeah, so if you group them like you did with the previous time, but you use the properties of logarithm, that if you have a log of the same base and you add it, then it's the same as multiply. You just take
Exactly.
the
So
side.
what you are saying that, I don't know, if you want, you can group them right now or you can group them later. So let me just do it like that. So you are right. So I would write logarithm of tangent of 1 degrees, yes, plus logarithm of tangent of 89 degrees, yes. But there are some technical problems here left, you have to solve them. It's clear that I will take the logarithm of tangent 2 with the logarithm of tangent 88, yes. Logarithm of tangent 2 degrees plus the logarithm of tangent, what? 88 degrees, of course. And then I can continue, but there is a little bit different. Something is different here. Here I had even number of terms, so I grouped them in group of 2. And that was complete. But here I have how many terms involved in this problem? Tangent of 1 degrees, 2 degrees, up to tangent of 89 degrees. So how many terms are involved? From 1 to 89 degrees, 1 by 1. So how much is that? 89 degrees. 89 terms, from 1 to 89, yes? So 89 is an odd number. So I can definitely not be able to group them in the group of 2. But which one will be left alone in this list? Yes?
Tangent of 45.
Tangent of 45. So 45 doesn't have any friend in that group, yeah? So if you continue this list, this list, hopefully you agree with me, here really we have to put these dots, otherwise we have to continue until the end of lesson writing these there. So what I will do is this, can you tell me, so what is left alone is tangent of 45 degrees and then logarithm of that one. There is no friend for this in this list. There is no partner here, but what is the previous one? Can you predict what will happen if I continue this list? I will go up to where? 44.
46.
Yes. So logarithm of tangent 44 degrees plus logarithm tangent 46. That is 46. Is that understandable? So what we have done, we have just rearranged these numbers in this particular pattern. Yes? So it means that I have some pairs of brackets to take care, and I have one single term to take care. Okay, but that is what Rocco mentioned. This is probably we also learned about logarithms this year as well. So this one can be rewritten in this form. Logarithm, it's an addition between them. I can write the same log, but I multiply these. So it becomes tangent 1 degrees times tangent of 89 degrees, yes? And this will follow for the next one. So this becomes the logarithm of tangent of 2 degrees multiplied by tangent of 88 degrees. And this list will continue until this one. So this becomes the log of tangent 44 degrees times tangent 46 degrees. But then I have to live with it. That's the only single term left. But that's not a problem. You will see why. So this number is what? 1, according to this rule. Alpha plus beta is 90, the product of tangents is 1. And this 2 plus 88 is 90, so the product is 1. So this is logarithm 1, this is logarithm 1, and this last one is also logarithm 1. But then I have to face with tangent of 45. But tangent of 45 is extremely simple to calculate, yes? I go and draw a right angle triangle, yes? So that one angle is 45 degrees. But if this angle is 45, because this angle is 90, what is left for this one is also 45. And this means that this length, whatever it is equal to that length. And if I want to calculate tangent of 45, I will take this length, let me call it x, which is the opposite side, but divided by the adjacent side, which is the same length. So then it becomes what? 1. So tangent 45 itself is equal to 1. Yes? So this means that this becomes also 1. So this means that I have a bunch of logarithms of 1 added. So up to here is here, and then I have one extra term here. But I really don't care about logarithm of 1, because logarithm of 1 is 0. And if I am adding a bunch of zeros, the answer becomes 0. So that's precisely 0, this combination. Yes? Okay, my goal wasn't to actually talk about these things, but this is something that we learned as a byproduct of our discussion. But the point is that now we want to go to the topic today, and that is the area theorem. Of course, it is not a big problem for you, even from might be kindergarten, you knew how to calculate the area of a triangle, didn't you? Okay, so then we want to find another formula for the area of a triangle which is useful, okay? And that is the title of the area theorem. Okay, so let me write this here. We have 3 types of triangles. This type of triangle that I have drawn, sometimes people call it an acute triangle. Acute triangle means that all the angles are acute angles between 0 and 90, strictly between. Or sometimes people call it a scaling triangle, yes? Of course, I can also have a right angle triangle. And I can have this scenario, which is called an obtuse triangle. Obtuse triangle means that a triangle whose one of the angles is larger than 90. Of course, I cannot expect two angles more than 90 because the sum of the angles should be 180 in the first place. Yes. So if I want to have an obtuse angle, yes, I can, but at most one. Yes. So these are the three different type of triangles that I face. Of course, we have some subdivisions, isosceles triangles, equilateral triangles, and things like that. But for example, equilateral triangle is of this type because all the angles are 60. All of them are. Of course, that's not a scaling. Let me clean this. A scaling means that the sides might be different. But in an equilateral triangle, the angles are all acute. So an equilateral triangle is of this type. What about an isosceles triangle? Can I say that isosceles triangle is this type with that type with that type? Isosceles triangle can be any of these types, yes? If I draw it narrow like this, with two sides equal, this is an acute triangle, an isosceles triangle. I can draw it like this. This is an isosceles triangle from this, so let me just draw it like that. This angle, I put it 90, and I take this side and that side equal. Yes, so then I will connect them. This is isosceles triangle, but right angle. And then I can have also obtuse one, yes? So this is not a good picture, but you understand what I mean, yes? I don't want to spend time on it, but it's here. This can be equal to that one, but this angle can be larger than 90. So when I talk about an isosceles triangle, it is not clear what type is until I tell you this angle for the apex. Apex is this vertex. Yes, in a right angle triangle, that's called apex. Okay, so, but now the point is that we want to find a formula, another formula for the area of a triangle. It's very important. And that, in principle, you know what is the formula for the area. So the area, in trigonometry, the area is denoted by S rather than A. This is standard, okay? So if I want to calculate the S of this, the formula is this. You can take two sides. Let me just write this A, C, and B. You can take any two of these sides, whatever you want, it doesn't matter. For example, let me choose B and C. I multiply them. And then I consider the angle between included by those angles. Included by those sides. In this case, if I choose B and C, the angle between them is A. I multiply this number by the sine of the angle between those two sides, and then I multiply it by 1/2 or divide it by 2. So this is called area theorem. So, but it doesn't matter which one I choose. I can equivalently choose the other two. For example, I can choose A and C, multiply them, and I ask myself, what is the angle included by these two sides? The answer is clear here, is what? Is B. I take sine of B, multiply these three numbers, but then I have to remember to divide by 2. Or, of course, I can do it with these two pairs. So I multiply A and B together, and multiply by the sine of the angle included by those sides, in this case C, and then it becomes 1/2. So this is the content of the area theorem. That's it, simple as that. But we first want to know why this theorem is correct in the first place. So be careful, don't get confused. You might ask Babak, this is not a right angle triangle, so why are you allowed to use sine of A? How do you answer this question? Because I emphasize that the formulas that I mentioned are valid for the right angle triangle, but even in one case I have the right angle triangle. I am writing this for this case, and for that case. you might have this objection that even though this is not a right angle triangle, how do you use sine of A? Am I allowed to do that? Because I realize that might be I said it wrong, I want to correct it myself. Is that understandable what I mean? Yes?
Say it again.
The point is that this sine, you might say that, okay, this is not a right angle triangle, so how are you allowed to use sine of A in a triangle which is not right angle triangle? Am I allowed to use this?
No.
I am. Because otherwise this theorem is wrong. Yes. You destroyed whole mathematics in 1 second. Yes. Yes?
So by like saying 1/2, I will like section the triangle so that we have two right angles.
No, that's not the answer. My question is that, is sine of A meaningful or meaningless in this context?
Meaningful.
Yeah. Now you corrected yourself. It should be meaningful, and it is meaningful. Might be I said it wrong. I didn't tell you that. I told you that the definitions that I wrote on the board are for right angle triangles. So here, if I say sine of A, you cannot say the opposite one divided by the hypotenuse. That is not working here. It doesn't mean sine of A for this doesn't have a meaning. Is that clear? So you cannot, if I ask you, if I give you this is 5, and if give you this is 2, or I don't know, 4, whatever they are, okay, 4, 5, 4 and 2, for example. If I ask you find the sine of A, you cannot use these numbers directly to calculate sine of A. Yes, because that is not a right angle triangle. You cannot say, in a right angle triangle, I can say the sine is equal to the opposite side divided by the hypotenuse. So sine of A is equal to A divided by what? We don't know. There is no hypotenuse here. So that is not correct here. But it doesn't mean sine of A doesn't make sense, because sine is not something, sine is something that we associate with an angle, with an acute angle so far. So for example, if A is 40 degrees, for example, and if you want to find sine of 40 degrees, it means draw a right angle triangle whose one side angle is 40, measure this length, and then divide this length by that length. What you get is a number. That number is the sine of 40 degrees. Yes? So whenever you want to calculate sine or cosine or tangent of an angle, first of all, you have to draw, in principle, we will learn a little bit different way later. You have to draw a right angle triangle whose one of the acute angles is the angle that you want to calculate, and then measure the sides and then divide them. It doesn't mean sine of 40. Sine of 40 is sine of 40. It doesn't matter if it happens here, if it happens here, if it happens here. 40 is an angle. You can talk about sine of that angle, cosine of that angle, or tangent of that angle, regardless of on which triangle it appears. But if you want to calculate it using dividing these lengthless, you have to draw it in a right angle triangle. Otherwise, you're not allowed to use the formulas. Yes?
So in that case, would like the degree of A be given in the questions, or would they still ask us for finding the degree at least?
No, they can ask you a lot of questions, but that is a different story. What I am focusing on is that I hope that I'm not confusing you, because I started by emphasizing that the formulas that I have written are only valid in a right angle triangle, and then I am writing a formula in which sine is involved, but this triangle is not necessarily a right angle triangle. I'm just trying to fix this error in your brain, if there is an error. I don't know. Might be I'm exaggerating it. Do you understand what's going on? Yes? Okay. Okay, but now why the proof is why these formulas are correct? Of course, where should be your starting point? If you want to prove a formula for the area of a triangle, what you're supposed to do, you have to start from what you know about the area of a triangle, which is the base multiplied by the height divided by 2. That's the only formula that we have for triangle. So it means that I have to start from here. So the point is that the question is this. Let me rephrase the question. I have a triangle, ABC, This is length A. This is B. This is C. This is B. I give you B. I give you C. I give you angle A. I give you these three pieces of information, and I ask you to calculate the area of the triangle. So let me write this angle A in this form. I give you the size of B, the size of C, and the size of the angle A. And I ask you to calculate the area of this. Okay, but you know the area is, what the area is. So, might be that is not a good, okay, so, but let me take this as your base and then draw this height. Let me call this one H. Okay, why is I am doing this? Because if I ask you, can you calculate the area? You would say yes. It is 1/2 the height multiplied by the base. Yes, that's the area. This we know. Yes? But the formula that I present should be in terms of the known factors. I know B, I know C, I know A. Okay, so I don't have any problems. That is no. B is given in my list. 1/2 is not a problem. H is not given in my list. So I have to get rid of H in favor of the known parameters. So I have to remove H and somehow replace something related to B, C, and angle A only. But then it becomes immediately clear. Why is that? Because if you just concentrate on this right angle triangle, it's a right angle triangle, so I can use the formulas. Yes? So for this triangle, I consider sine of A is equal to the opposite side, which is H in this case, divided by the hypotenuse. Hypotenuse is the side opposite to the 90 degree angle, okay? So this becomes C. Is that understandable? So you see, you might say that, so first of all, am I allowed to write this formula here? Yes, because I wrote it in this colored region. This colored region is a right angle triangle, and I told you that in any right angle triangle, I can write those formulas. So sine is opposite side divided by the hypotenuse. And then immediately, I multiply everything by C, so this becomes C sine of A is equal to H. And then I will take this one and put it back here. Then becomes S equals to 1/2. Instead of H, I would write C times sine A. And then I multiply it by B. But instead of writing it in this ugly way, I would write it as 1/2. I combine B and C next to each other. I put them next to each other and then multiply it by C. Okay? That's the formula. So, if you want to find an area, but this formula will remain valid here and there as well. Yes? So let us check if this formula is also correct for this special case and that special case. For this case, it's also valid. Why? Because you see, I draw this height. Yes? But the story will remain exactly the same. So if this is the height, and then I will write sine of A. Actually, you see, if you read what I have written here, it is independent. You can do the same thing for this picture. You can also do the same thing for this picture. It doesn't matter. Because again, sine of A is the opposite side divided by the hypotenuse. So exactly, I can write exactly the same thing without even slightly change for this one, and for this one. So this means that it is always valid. So I want you to remember, and of course this is given in the formula sheet, but it is good to remember. If you want to find the area of a triangle, you can do it a little bit differently now in trigonometry. You can multiply two sides, multiply it by the sine of the angle included by the sides, and then remember at the end multiply by 1/2. That gives you the area of your triangle. So that is the area rule or area theorem for triangles. Is that understandable? It's very, very simple. Okay, so let me solve some of the problems in the book, because this is just half a paragraph talking about these things, okay? But there is one point that you might ask me here. And that is this point. Because I told you that it doesn't matter which angle you choose, you can do this. For example, let us consider this scenario. Let me just redraw it again here. For example, something like this. But let me take this B in this time. So this is B, and this is C, this is A. So this is C, this is B, this is A. Can I write area, which is S, is equal to this side multiplied by that side, 1/2 C A sine of B? Yes, that formula should also work here. Yes or no? This formula should work. Because actually I found the formula, by the way. But there is something very strange happening here, because this angle is an obtuse angle. Yes? But we don't know what is the sine of an obtuse angle. Because whatever we learned about calculating sine is the sine, cosine, and tangent in a right angle triangle, and the angles are acute angles, so they cannot be larger than 90 degrees. But apparently we are in trouble now, because either we have to leave this formula away, or there should be a way to give meaning to sine of B, even though B is larger than 90 degrees. If I ask, for example, assume that this is 110 degrees. You cannot use this method to calculate sine of 110. Because if this was 40, you could do it somehow. You draw a triangle, one angle is 40, and then you would say that sine of 40 is this one divided by that one. At least in principle it is possible. But now let us assume that B is 110 degrees, and I ask you to calculate sine of 110 degrees. So what happens? You cannot do it like this, can you? Because you cannot draw a right angle triangle whose angle is 110. Yes? But still, if you punch sine of 110 in your calculator, you get a number. So this means that there is a meaning for sine of 110. So this means that somehow, either I have to leave the formula of area, and I say that formula of area only works for acute triangles, or there is a better way to extend our understanding about sine and cosine and tangents so that they also include obtuse angles. This part will be done in section 1. We come back to it later. Okay, but I just want you to understand here. But for example, let us ask you some question. There is a very nice trick. Right here, using the area rule, you can calculate sine of 90 degrees. And immediately you can also calculate cosine of 90 degrees. And if you have sine and cosine, you can calculate tangent as well. So can you do that now? Without calculators, using the area rule. So let me consider this right angle triangle. Yes. Let me take this one A, this one B, this one C. I calculate the area of this triangle in two different ways. One way, as you learned in primary school, how do you calculate the area of a right angle triangle? Let me give this A, this one B, this one C. How do you calculate the area? Base times the height. But what is the base here is C. What is the height here is B, and then divided by 2. This is on the one hand. This is what you learned actually in primary school. But now, if this formula is correct for this right angle triangle, which should be, at least for this case, then what can you write this area? The area is equal to 1/2 this side multiplied by this side multiplied by the sine of the angle between these two sides, which is 90 degrees. Yes? Agree? Okay. So if this formula is correct for every case, This should be correct. This formula is also what you learned in the primary school, but this number should be the same number because you are calculating the area. You cannot get a number for this way, in this way, another formula, another number in this way. So this means these two numbers should match. So it means 1/2 BC sine of 90 degrees is equal to what? 1/2 BC. And then what happens for sine of 90 degrees? So which value should be this number? A number so that when you multiply it by 1/2 BC, gives you 1/2 BC, yes?
It's 1.
It's 1. So it means that sine of 90 degrees, your prediction is this. Sine of 90 degrees is 1. And then of course we know that sine squared, we will learn of course all of these things will work. Sine of squared plus cosine of 90 squared is what? 1. If sine 90 itself is 1, what is the contribution coming from cosine? Nothing. Is 0. This means that cosine of 90 should be 0, yes? And what is the relation, by the way? I didn't talk about this, we had this before. So you see, I should have mentioned this before. So here if I have B, if I have this A and this I have C, let me see. If I ask you what is sine of B, you would say the opposite side divided by the hypotenuse. If I ask you what is cosine of B, it is the adjacent side divided by the hypotenuse. If I ask you what is tangent of B, you would say the opposite divided by the adjacent. But let me divide these two. If I divide sine B over cosine B, what happens? When I divide this by that A and A are gone, I get B over C. But B over C is exactly tangent. That's also extremely important. Of course, I will consider these things later. So tangent of an angle is equal to the sine of that angle divided by its cosine. And of course, if I now ask you what is the tangent of 90 degrees, you will see something interesting, yes? Tangent of 90 is what? Is sine of 90 divided by cosine of 90. But sine of 90, we more or less calculated to be 1. Cosine of 90 is 0. So what does it mean? It means it is undefined. And then if you punch it in your calculator, you will get an error. So tangent of 90 degrees is not defined at all. There is no number for tangent of 90. But sine of 90 is 1, cosine of 90 is 0. If you ask me how did I get it, I would say that I compared the formula we had before and assuming that this area formula is also valid for all cases. Okay? I'm just trying to give you some ideas how this goes. Okay, but let me now solve some practical problems. Problems are actually very simple. So for the time being, some of these problems needs your calculator. So make sure, so please punch sine of 90 in your calculator. If you don't get 1, it means that your calculator has been set on radian mode. You have to switch it back to the degree mode. That's essential. Be careful. In the national exam, test your calculator. Sine of 90 degrees should be 1. Or tangent of 45 degrees. We calculated to be 1. Punch one of these. If the answer is 1, that's correct. It means that you are in the right. And of course, you see some D or R on the display of your calculator. On very small R or D on the top of your display somewhere. Yeah. If it is R, switch it to D. R is radian, D is degree, okay? Okay, so now we need your calculators. Some of the problems need a calculator. Okay, so I don't know. So this is a very, very simple problem. So they have given you this triangle. I try to draw it somehow. So, but I need your calculator. Someone can help me here. So here, this is given to be B, A, C, and then this side is given to be 9.8. Everything is in centimeters here. And then B is, so let me write comma here. So 9 comma 8 and then 7 comma 4. And then this angle is given to be 34 degrees and you are supposed to find the area. That's a standard problem, isn't it? So it's the standard problem. Why? Because the lengths of two sides are given and exactly the angle that you need, the angle included by those sides are given, and you're supposed to find the area. Okay, so the area is what? There are three formulas for the area, but it is clear which one is suitable in this context. The one including B and C and angle A. Yes? So this becomes 1/2 B times C times sine of A. Then it becomes 1/2 multiplied by B is 7 comma 4 multiplied by 9 comma 8. Yes? Multiplied by this part you need your calculator in the correct mode, degree mode. This is not something that I can calculate in my head, so you have to punch everything like this in your calculator, and then probably they will ask you to, by the way, how many significant figures are involved here? Two. Okay, so whenever it is a measurement problem, you have to keep two significant figures, the lowest one given in the problem. Okay, so let me just multiply everything. Can you give me the number? I can cheat a little bit here. It's approximately, I don't know why they have mentioned it. Okay, so it is approximately equal to 20 comma 3. You have to write the units. The lengths are expressed in centimeters, so it's square centimeters here. But how many significant figures we have here now? 3, so I have to reduce it to 2. So I have to get rid of 3 here. But I round it up because 3 is lower than 5, so I would say that S is approximately 20 centimeters squared. This is the way that they have solved.
Also,
Yes.
if on the other hand C was equal to 9, for example, then it would be one significant figure, right?
Yes.
And then how would we express the answer?
But then you have to, if you want to write it one significant figure, then you have to write it as 2 times 10. You have to use the scientific method.
Okay.
Yes. Okay. So that is one problem. There is another problem that I want you to solve. You have to memorize this part for the time being because we haven't talked about sine of obtuse angles. But let me just first mention the problem for you. But the reason will become clear when I started teaching you the first section. Okay, so the point is this. They have given you this question. There is not a triangle. They have written it in words. There is no figure for it. You have to draw the figure yourself. So we have a triangle ABC. I'm just reading it. A triangle ABC is assumed. And then we know that the area is 25.2 centimeters squared. We know that. We know that the side AB is equal to 7,2 centimeters. And we also know that side BC is equal to 8.3 centimeters. Determine the angle between these two sides. Determine the angle between these two sides. Which angle is that? Can you tell me? AB and BC is B. So we want to find the angle between them. So this means that the angle B is wanted. This is the point that you have to memorize right now, and then we will come back later. You will see why. The reason is this. What should I do? I have to write. So I go to a scratch paper. I sketch something for myself. I don't even care if it's true or false, but I have to be careful. So this is ABC. I don't know, AB is this one, 7.2, and then BC is 8.3. And then I want to find, oops, BC is this one. BC is 8.3, and then I want to find this angle. It's very simple, yes, because you have a formula for the area. So area is equal to, in this case, the opposite side is A, the opposite side is C. So let me write 1 over 2 A times C sine of the angle between them, which is sine of B. This is the formula, yes? But S is given 25, 2 is equal to 1/2. A is also given 8, 3. C is also given 7, 2, but angle B is not given. So this means that I don't know sine of B. But I can do the rest of the calculation. So if I multiply this by 2, it becomes 50.4. And I divide by 8.3 and 7.2. And I ask for your help to do this one for me. This is sine of B. Yes, so you divide this by that and then divide the result by this one as well. So what is the answer? Can you tell me?
Do you want a decimal form or?
Yeah, just this one in decimal.
Oh, 0.84.
So sine of B is 0.84, yes?
Approximately.
Approximately, yes. Yeah, that's good. We have two significant figures. So what was the next to it? What was bigger than 5 or the smaller?
No, it's 3.
Okay, good. So, but then, do you remember, this is a Math 1C lesson, you have sine of B, you want to find B. What do you do with your calculator?
Oh,
Yes?
Shift, then it would be sine minus.
Sine inverse. So what you do, this is the point that I want you to memorize. Sine inverse of 0.84. And then can you just calculate this, please, Robert, in your calculator? So what's the answer?
57.
B is what?
It's 57.14.
57.1
0.1.
Degrees. But then let me go to two significant figures. Yes, the lowest one. So so B is what? 57 degrees. Yes.
Yes.
Something like that. But the point is, this is not wrong. It's completely correct, but not complete. And this one cannot be calculated using a calculator. You have to calculate it using your trigonometric knowledge. That you don't have it right now, just memorize it for the time being to be able to solve the problems, but I will teach you. There is also another angle. And that is the supplement to this one. Supplement means the sum should be 180. So this is what I want you to memorize for the time being. So if you use sine inverse, the calculator is only capable of giving you the acute angle. But there is also an obtuse angle involved, which you cannot see. For the time being, memorize it. I will come back to teach you later when I am teaching the section 1. So this means that this is the or part, you don't see it in the calculator. It's B is equal to 180 degrees minus 57 degrees. Okay, and this angle is what? How much is 123? Am I right?
Yeah.
So the answer, one of them you understand fully, 57 degrees. But there is another answer that you, at this point, you have to memorize. If sine of an angle is equal to something, and you want to find B, the one provided by the calculator is not the whole story. The one provided with the calculator is one of them. There is another one which is always, we will see why always this is the case, is the supplement, not complement. Supplement of that angle provided by the calculator. Supplement means 180 minus that angle. Complement means 90 minus that angle. Yes.
why isn't it 360 minus 57?
No, I told you. You have to wait a little bit patient, memorize it right now, but you will come back to it later. Okay? So there is another one is in this case. So it means that this triangle is not unique. There are two triangles with that property. Okay? One of them So one of them is this. So let me just try to give you some feeling, yes? So one triangle that you have, for example, we learned that this is 8, 3, 7, 2, and then we learned that this angle is 57 degrees. It's not a good picture, but anyway. Okay? There is another one, which is this one. The same length here. Yes? The same length here. Of course, you can also understand it why 180 is not 360 degrees.
Oh.
Okay? So you see, I tried to copy and paste this length. I tried to copy paste this length. And then this one. Yes? If I ask you what this angle is, this angle is 123 degrees. Yes? The areas of these two triangles are exactly the same. How do you see that the areas are the same? So, I mean, this is a bad picture. Let me write a little bit better. So it should be exactly the same length. And then this goes from here to here. Something like this. So, can you convince yourself in another way that these two triangles should have the same areas? Yes?
If they are the same base and height, then their area is the same.
Exactly. And the base, I just drew it myself like this. The base is the same. But the height of this triangle is this much, which play the role of the height of the next triangle as well. Yes? Because if I ask you what is the height of this triangle, if I ask you to draw the height from this point, of course, because this is an obtuse angle, I have to extend this and draw this line. So this line is the height of this triangle. Yes. So this means that based on this picture, you really understand that there are two triangles with the same properties. This side is 7.2, this side is 8.3, and this angle in one of them is 57, the other one is 123. Yes? Now you understand that if I change this a little bit, the height will start changing. The heights will no longer be the same, so the triangle will be the same. So this is the only part that I wanted to memorize for the time being. So if you want to find B in Math 1C lesson, you didn't face this. Why? Because we only work in a right angle triangle. In a right angle triangle, only acute angles can happen. So this is why in Math 1C we didn't face this problem. But now we face this problem because we want to find all possible angles. So remember this one. If you use this model, calculator will always give you the acute one. But if you want to find B, there is another one, which is the supplement. And you have to write it yourself, yes.
Why does the calculator only give the acute angle?
No, because that's the way. I don't know how GeoGebra acts, but yeah. Because there is a reason for that. Sine inverse is a function in mathematics. And when you have a function, it means that whenever you give an input to it, it gives you one output, not two outputs. Yes? Okay. That's the reason. Okay, so let us see if we can solve another nicer problem. So there is a double star problem. Let me write it down, and then you can help me to write it, and then we are done. We have a little bit of time, so let me just solve that one as well. I don't know even, I haven't seen the problem myself, but I see that there are 2 stars on that problem. Let us see why this is 2 stars. It's very tempting when you see stars in the problem. Okay, so it's 5075. It's from the course book. So let me try to, if I can, draw them somehow the figure. Okay, so it's hard to draw, but shorter even. Something like this. So this is given to be new, or new actually. This is the Greek letter. It's not a V, or I don't know, you can call it V. It's something like V. Okay, so this is 15. This is 12. Of course, comma 0, 9, and then 6. Yes? And then everything is in centimeters. Okay, we are supposed to calculate the, okay, might be we are not able to do that. Okay, let us see, because we want to find this angle so that the area of this shape that you see is 54. So the area of the whole shape, that you see here is 54 cubic centimeters. And then you are supposed to find this angle nu. I'm not sure that we can solve it, but I think we can. No, we can. Yes. Oh, can you help me to solve the problem? Yes, real quick.
So I can see that there are 3 triangles, so if we could somehow use this formula for each one of them and then add them up to be equal to 54, we could solve it.
Yeah, so I don't know why this is a level 1 2-star problem. Okay, but anyway, you are right. So the area of this triangle is what? So let me write S is equal to S1 plus S2 plus S3. Yes, these are the areas of these triangles. But for the area 1, S1, I can write the area formula that we learned today for this triangle. So which is 1/2 multiplied by 12 multiplied by 15 multiplied by the sine up the angle between them, which is still I don't know. But 1/2 and 12 becomes 6. 6 times 15 is 90. So this is just 90 sine of V. V is still not known, or nu, or I don't know. Let us write V. Or nu is better, yes, V. Yeah. Okay. And then what is S2 then? S2 is 1/2, but these two sides and the angle between them. So this becomes 1/2, 1 times 12 times 15, sine times 9 times sine of nu. So this becomes 6 times 9, 54. Now please check my calculations if I'm wrong. So S3 is equal to 1/2 this side times that side times the sine of the angle between them. So 9 times 6 times sine of nu, yes? I'm writing the same formula for 3 triangles. And then it becomes 27, yes? Did I do any mistakes here in my calculations?
No.
Now we have to add them. And the sum we know. What is the sum? Is 54. So this means that okay, so that's a good problem that we chose actually, I think, for one reason. So let me add them. So this means that the sum of these numbers, 90 sine of nu plus 54 sine of nu plus 27 sine of nu is equal to 54. That's how I write the numbers, are these numbers, yes. Okay. But then what can I write for the left hand side? I have a number, 90 of them, 54 of them, and 27 of them. I'm adding them, yes.
Factor sign or something.
Yeah, factor sign or just simply add them. Factor is also correct. But why should I factor? Because I have 90 of them, 54 of them is added to it. So it becomes 144 of them. And then 27 of them is 171, yes? Yeah. Is equal to, and check my calculation.
That's correct.
Okay, and then I need to find sine of nu. I make it alone. So sine of nu becomes 54 divided by 171. But be careful here. And so nu is sine inverse of 54 over 171. And then what you get is in your calculator. What is that one? Can you calculate this for me?
18.408.
18.
40848.
0.0
408.
408.
Maybe.
Yeah, that's good. 41 degrees. This is the one, by the way, we have to be careful here. So it might be that's the reason that's a double star problem, okay? Of course, I told you that whenever you want to calculate sine in this context, this is one that's given with your calculator, but there is another one. So if you don't mind, let me get rid of this one to make things simpler. And in principle, I can get rid of 4 as well, okay? Let me just keep it 18 degrees to make life simpler. Approximately 18 degrees. Okay, I told you that there is another angle which calculator will not provide for you. So what's the other one? Is 180 minus 18, which is 162. But is it acceptable in this problem? Be careful. The angle, the next angle is this one. No doubt about it. There is another angle whose sine is this number. That angle is this one. But look, in this context, is it acceptable? No. Because if one of them is supposed to be this one, 3 of them will be even more than the full circle. Yes? So in this context, it doesn't work. In the previous problem, it worked. Yes? It doesn't mean that you should ignore that. You should understand it and then see that in which context you are working, is it acceptable or not. In this context, if you ask me what is the angle whose sine is this number, I can tell you these 2 angles. That is correct. But this angle in this context is meaningless. Yes? So this means that 18 degrees is the only answer. So let me check the answer and then I will come to it. Okay? So let me double check it immediately. Problem 5075. Yes, they have written 18.4, so the first one. Yeah, but I was a little bit lazy, so 18.4. So because I wanted to calculate it, but the correct one is 18.4, which I.
Also,
Let me answer Roku first.
okay, sure.
So, if you were to give this problem on a test, do we need to show and motivate why it can't be the other angle, or can we just write 18, or do we need to
No,
show
I
that?
think it's better to write.
Well,
Because for example, even if you solve this equation, you write x is plus or minus 2, and if one of them is not acceptable, you say that this is not acceptable for this reason.
So we need to say,
Yeah,
always say that the other one is not acceptable.
Yes,
within
at
the
least you
context
should
of-
say that in this context it's not acceptable. Yeah, I think
Okay.
it's better to mention.
Yes.
Yes.
How are we supposed to write 18 when we have like only one significant?
It's very vague for me, these questions,
Yeah,
but
for me too, but
it's not very clear exactly, because with the angle we don't know. So
the lowest like
they have used 2 significant, because they have written 15,0. I wrote it 15,
Okay.
but the problem in the book they have written it 15,0.
And 6,0.
6,090. So
So
it
then
means
it
that the
would be
lowest one is 2 significant.
Okay.
Yes. And I think that I respected 2 significant figures here.
Yeah.
Uh,
They didn't.
But they have written it 18.4, which is 3 significant figures a little bit.
It's because they're down.
Yeah. Let us see. Anyway. Questions? So I will update the Google Classroom so you can start. So I think 2 more sessions, if I teach, we will finish this part. But then, of course, the important part is the section 1 that I skipped. So we'll go there. Thank you very much.
Thank you.